Alright, so in previous video we understand a lot more things about the Pearson correlation coefficient, and in this video we will talk about like how to calculate this correlation coefficient. And for that I have got one matrix for you over here, right? So this is the data which we are going to pick up, and we are going to sort this up, right? First thing first, I would like to write down the formula over here, and the formula for calculating the Pearson correlation coefficient is R equals to summation of x comma y, right? This is small x and small y, and if you divide it by the square root of summation of x square, right, and then you need to do multiplication of y square. Okay, now what is this x and y, right? We want to talk about this, right? Now first thing first, you need to understand what is this x and y, and x and y are nothing but the values we have, which we have derived from capital X and capital Y, right? So we have these two values, right? So first thing first, we have this x, right? So capital X over here is my raw score for observation. Okay, raw score, right? This is my raw score. Okay, raw score means that this is the value where I'll be creating graph. So if I create graph, I will have capital X and capital Y over here, and I have some values over. I don't know like how this graph will be like, but this is capital X, right? This is my raw score. Okay, and then we have you can see that we have something called as small x, right? which I'm just writing it as small x, right? So we have small x over here, and this small x is nothing but the deviation score of observation. What is deviation score? I'll just talk about that. Deviation, this is my deviation score. Okay, and then we have x bar, right? And this x bar is the mean of all the score, mean of all score, right? All raw score basically, right? So let's understand this over here. So we have this value of x, right, which is something like this, and we have value of y. And what am I going to do is I'm going to apply some formula, right? And the formula which I'm going to apply is the sum of the total sum of this the data which we have is, I'm going to say sum of this all values will be calculated. Sorry, I have to write sum, and then I would say need to pass on all these values, and then you do this, right? And how many values I have over here? I have 18 values, so I can just simply say this value divided by 18, right, is my average. Or you can just simply pick up average formula also, right? So you can just simply say average of all these numbers, show me these values. It will be almost similar, right? So we can say 5.61 for like, better understanding. So let's pick up this value as well. Let's see what we've got over here. So M21 is also, you got the values of all these values over here as well. You got 15.5. Now what we want to do is we wanted to calculate the deviation score, right, which is small x over here. And what is my deviation score all about? Which means that I wanted to pick up the values of capital X, right? The value of capital X, something like this. So I would say, what is my deviation score? This value, right? This value. And after calculating this value, I wanted to have a like difference of mean versus this. So this minus, and I would say this value. Okay, I would say dollar this value, right? I'll fix this value. So I'll just rather, I would say 5.61, right, which is 5.61. okay, this is what I wanted to know. So I've got all these values over here. Let's see if Excel is calculating right. Yes, it is also calculating right. So I wanted to have this value as well for the x value. Similarly, I wanted to have the value of y as well, very much similar to that. I wanted to have value of y, so it will also be difference of 5.67. so but here the average of y need to take, which is 15.5, so I'll say 15.5 over here. Okay, and once I calculate, this is what I've got. Okay, so you got the x and y value as well. Now what I want to do is I wanted to multiply x and y value. So I would say, what is the value of x and y? So I will say equals to this value multiplied by this value, right? And I'll hit enter, right? So got some values over here, right? And I wanted to sum them up, right? I wanted to sum these values up. So I would say sum these up. It's a sum of these values, and I wanted to pick up x square value, x square, right? I would say x square, I'll write x2 over here, and then I'll write y2 over here, right? So you can understand it's an x square. So I would say this value is x into x, right? And if I do, I'll drag this over here, you get all these values, and here I will drag the sum as well. Similarly, I want to drag this value, and I would say this will be a summation of y. You've got all these values, and I want to drag this value as well, so that I can see the summation of y square, right? So now what I have done is I have calculated everything, right? So now it's time to put in everything into the formula. So I would say r equals to, right? So I would say summation of x into y is something like this. I would say divide this value by this, right, which is summation of x square multiplied by summation of y square, and I'll close this bracket, and I'll get this value over here. So what I get to see over here is 0.005, which is my Pearson correlation coefficient, right? This is my Pearson correlation coefficient, 0.005, which says that there is barely a relationship between x and y, right? However, if I change this data, and I'll give you some other number, right? Some other numbers, like I will just change this data as 0, and I would say this is 2, and we have 2 again, and then we have say 4 value, and then we have something called 8, and I have something called as 2, and the y value is say 1, and then we have 2, this value is 4, this value is 5, this value is say 12, and this value is 3 for that matter, right? Then what is my mean value over here? It is 1, L3 minus 1, and I will derive this over here, right? And this, what is the value of average over here? 1.5. So I'll derive my 1.5. I'll drive 1.5. Okay, and this will be my y value. What will be my x multiplied by y? Is something like this. What will be my x square? Something like this. What is the value of this I get is something like this, right? And then I can calculate all these values again, right? I would just simply calculate this value, and I get to see 0.0109, right? So I can just wanted to show you that this is how you calculate the r value. And if you okay, I think I have not put in the square root of it. Okay, right? I would say square root of it, square root of this value. I will calculate this SQR, square root of this multiplied by this value. No, sorry, it has to be P22 square root of this value multiplied by this value, and if you close this up you get 0.98, which is a very good score, right? It's very much close to positive correlationship. So 0.98 is very much close to perfect relationship over here, right? So you can see over here the R value is, it is called Pearson correlation coefficient, and we can say that X and Y are heavily correlated. Maybe you want to insert a graph over here, and I think if I can do that. So I would say I'll not pick up this graph. I will say I want to change the data. I wanted to pick up this graph, insert a graph over here. It is picking up all the data. I will say select data, and I wanted to select the data only for X and Y over here, and I would say show me the data over here. It's not selecting the right data, basically it's changing the data to this. Maybe this is not the right approach, but yeah, I hope you're getting this point over here. The correlation coefficient comes out to be 0.98. Probably I can show you this with Python programming, and will make much more sense. It will start making much more sense when we talk about the Pearson correlation coefficient in that matter, right? So I'm not good with Excel. Yeah, it works. Yeah, it works this way. Yeah, so you can see over here you've got a very good correlation over here. Only one point which is deviating, rest everything is pretty fine, and it's showing a positive, very positive correlation over here, right? So I guess you got the idea over here, right? And what this value is all about, and how we can actually start working on the relationship, like what this relationship is all about. I hope it makes sense. In the upcoming video we'll talk more on this, and we also wanted to understand that there is a slight transition which we have made from univariate analytics to bivariate analytics. I'll see you in the next video.